Hello friends, and today we are going to continue our Go studies, TDD way of course, many thanks to Chris Jones. Oh sorry friend, Chris James. You can see him here, U-double-I. So, and here's the website, it's here, and that's the website. So yeah, that tells the story. Now, back to the business. Here, we did iterations, right? Now it's about arrays and slices. Let's see if we can do it in one go. It will be a big go, but it will be one go. Now, interesting. Let's do it. Let's do it. And sorry for this noise outside. There is a window and it's raining and it's night, and well, friends, I'm doing that for you and for myself because Golang is so cool. So let's see. Visual Studio Code. Let's see how it works. Okay, so this stuff we don't need. Also, Control K W. Nice. Ooh, that's a real array. I think it's this one. Arrays. Oh, 8 of them. Which is a very big topic. So I'm not so sure now. To be honest, let's just start because I'm quite tired. I thought it will be shorter, friends, really. So apparently, well, that's a normal test, and yeah, that's a normal test, and I'm sorry for this noise. And probably will have to cancel the stream because of the noise. Really, that will be quite interesting developing while it's raining. So we know this stuff, but this stuff obviously means that there's an array of 5 integers and we set the values there, right? If you go back here, there's a sum. Now, let's see, package main, and this thing gets get numbers. Yeah, obviously, yeah, of course. So here we just call the function sum. It's a public because it starts with the big one, and here all we do, we just add numbers as it goes. Now the only question here is how they compare. So, so we just sum them up. Okay, cool, easy. So that we could do, nothing serious. This one. So you see, friends, I'm quickly going through the code because code tells me more than the description. Description here is just words, right? This is how it works, not that. Here we might have a typo, but here, well, it's either runs or it doesn't run. So of course there's a probability of a problem with the compiler, but you never know. Oh, sorry. This thing needs some oil probably. Now, let's see. So what did he change? Did he change anything? So this way and this way. Oh. So here if want not equals got, and here if got not equals want. Why? What's the explanation? So is it because got can be a null? I'm not sure null exists in this language. Haven't seen it yet. And So yeah, friends, it looks like I'm not that young any longer, so I really will have to finish this one, and then next time we'll start from part 3 of arrays. So they have fixed capacity. That's cool. The test. Oh, that's cool. This is cool. Now, enough code to make it pass. This is also cool, I guess. Well, yeah. Now, oh, this is interesting. So here, we introduced range. So, interesting. How does it work? So we know size of the array. So I here, I is not really, well, I is needed here because we need to know the index. But here in the range of numbers, we just tell number. So apparently in 4, so this one I think will be like E, or I mean I, right? Of course it's not used here, but j equals I, right? And then j is not used, right? Plus I minus I, something like this. I'm just fooling around. I was just checking because I think this one is the index one, but when you don't need it, you can make it like this, right? So I've seen it somewhere. It's not my first time when I'm trying to learn the Golang, but that's the best time. I've tried Coursera, and with all respect to Coursera, well, this approach is so much better. So, oh, code first approach. Yeah, it's imposter code first approach. Enjoy. Now let's see. So when we do range, it creates an index and it creates value from the cell. So if you don't need the index, you just do this underscore thing, and yeah. Because if you put here I, then almost said IntelliJ, then Visual Studio will say that wait, you need to use it. But if you just do underscore, no need. Now, on each iteration, range returns two values, the index and the value. Okay, that's easy, so it's called blank identifier. So arrays have type. Really? So this has type of int, so it can hold a number. Okay, and I think this will be number. This will be number 4. Well, this is not a very long. Let's see how many I get. Let's actually just go through code. So if you compare this with previous one, if you check, I don't understand why he changed the order here, because this order changed, right? So I want to see in the text, right? Why did he? Maybe it just happened, you know. Maybe it, well, he was just doing something, and right, and then so here got not equals want, and here as well. So yeah, I think maybe even if we go here, it will change again. Now it's got not equals want. What not want not equals got. What not equals. So maybe it's like no difference at all whatsoever. There is no reason. So here we create an array of any size, but you see here we declare 5 and we create this array, but here we don't. We just create array, and because it already knows how many elements are there. So I guess in this one, these elements, so if I could put there 15. Oh. That's interesting. But if I deleted this one, yeah, it would have worked, and I think the fifth is will be 0. So this number will be not 15, it will be 10. Let's see. If this one is 0, then the answer will be 10. Yeah. So you can define big array and set only a small part if you wish so. That's nice. So you can make it start with, I don't know, 1 or 50 and then have 1 million elements, zeros. That's how it should be. Now write enough code. So okay, today we are going code-driven thing. So here, so this one, it's exactly element, array of 3. So and probably this one expects. Oh, you see the difference? You see the difference? So here in sum we expect 5, but here in sum we expect whatever. It's dynamic, right? So that's the biggest change. So yeah, the remaining is the same, and range allows to, well, go through any size. Now you see how much better it is, how much faster it is to read code first, because a lot of this stuff I know from other languages. I know Python, Java, whatever, you name it, and Visual Basic, .NET, whatever. Actually I did some Pascal when I was, well, when I was at school, and my father made me do it. Well, he supported me, and yeah, and then I could play computer games after that, so yeah, it was a good deal. Now if I run it, let's see what is going on here. So here we have the first test and the second test. This one, 1 plus 2, 3, 3 plus 3, 6. So this one is clear, right? It works. It's okay. You see, here it says okay. But what about that one? That's an interesting question, right? Yeah, this is interesting. So what do you do? Test sum and test sum all. So there is apparently method sum all. So this just takes an array, right? But this takes multiple arrays. Oh, sorry. This is obviously a test method, but this one, yeah, somebody needs to sleep. But we already half through. But this one, comparing to sum, you see, sum gets one array of integers, but this one gets multiple arrays of integers, and it returns an array of integers. How does it work? Oh, so it takes this one, 1 and 2, 0 and 9. So it sums this 2 for the first element and this 2 for the second, I guess. So let's see. So here, what is this thing? So, well, so apparently this one creates an array of integers of such length, which is the length of, so len is the function which helps to find the length of the numbers to sum. So it tells how many arrays are there, or there are, right? And now when we know how many arrays there are, so we have these sums, and now for each array, why would you need this? Oh, it's just length, right? But like, really, what's the point? Because you see here it's only used here, and that's it. So I could probably like inline it and that's all, right? So I could do just that. And it would still work. So this is not really needed. Okay. Well, that's me. Control S. Oh, that's of course, because that's the implementation. So here, if I do it again, will it be okay? Yeah, it's okay. So there's no point to, well, sometimes there's no point to use a variable separate one when it's not reused anywhere. So like, why? Why would you do that? Unless it like changes maybe, but no. So, and here then we go through each number and then to the element. So for each array, because for the numbers of arrays, let's say there are 5 arrays, for each array we sum its cells, whatever, and then we put it in the I cell of this new array. So we have 5 arrays, and then if you have 5 arrays, then you can have 5 cells here, and let's say in the first one was the sum was 100 and the last one is 1000. So will it be? Now let's see. Let's see this thing. Okay, now let's see version 5. So what do we do here? Okay, let me see. How do we do it? Put it on pause. Oh, it's this. Good stuff. Now let's run this test. Let's check if it works. So here we have test sum and test sum all. This one, this we knew, this we knew, this we knew. Here, what did he change? What did Chris change here? So we have 2 arrays and we're getting this one, but this one is interesting because what he tells now is that there's apparently a difference. So here, oh, we missed it, did we? So here we have this reflect thing, and what reflect does, it has a method called deep equal, and it checks the, so you see here we just check the sum, right? Sum of numbers in the array, but here we are making sure that the array we are getting, that array we get, so that's what we are getting, equals to this one. It is that's here we're making sure that what is returned is an integer array length 2 with 3 for the first or 0th and 9 for the next one element. So that's easy, kind of. Well, it depends how, because I've just seen it so many times, similar stuff when I was small. But well, if that's easy for me and not easy for you, it means that you are much better in some different part of this very language. So let's see. It's actually sometimes when I say easy, it's not easy at all. So, well, liar, liar, pants and fire, right? Was it the same? Some test. Okay. Okay. So let's see. So this one didn't change much, unless it changed here. Not really. Now, which means it changed here. So in sum here and here, we have, okay, so here we declared variable and immediately initialized it, set with the value, okay? But here we first declare that we will be having a variable, therefore var, and probably then we'll fill it. Oh, so we are going through those numbers and we are going to append. This is interesting. Now I have a question, because now it depends, because for example in Java you cannot modify the length of array. For example, you have class ArrayList, and which will have some length. It will have an array of specific length underneath, and it increases, and when it reaches this length, array doubles in size. Well, of course there's a limit, I think it's max int, but still. So here we are in version 5, we are prolonging the array. Instead of creating a big one immediately, let's say there's 1,000 elements, 1 million, 2 million elements, right? Well, I don't know how big int is in Go, but maybe int is, I don't know. Actually, you can check it. Golang int size max. Oh yeah. Okay. Wow. That's interesting, but that's not normal int, that's max int, right? What we need is probably that. Ouch. So int is signed. Okay, so it's 10 and 9, 2 and 10th, right? Which I don't, well, that cannot be, that's too small. Yeah. 1024, really? Interesting. Now, let's see. So, we wanted to check what? We wanted to check this stuff, and we wanted to check append. Or at least I wanted to, but because we wanted to see how does it affect the performance. Oh, so there was a slice somewhere. So slices is, where did we take it? So here we did a slice somewhere. So here, so we're comparing God and Bob. How on earth? Oh, so the test compiles because we are comparing string to number of arrays, but it doesn't. Okay, that's interesting. So does this text actually? It will be this one, right? No, this one. Or maybe it was just an example, right? It might have been just an example. Now, okay, so what Chris is telling here is that although we have this dpq in the Reflect, which is really cool and useful, it has a problem. Oh, pardon me. It allows you to compare incomparable. We're comparing oranges and horses, whatever, cucumbers and, I don't know, blocks of salt, although cucumbers go well with salt. Somebody's hungry. Now, I promise you we are close. So now, let's see what do we have here. So DPQ we know, this we know, that we know, nothing new. Here is the append is cool. This we already knew, so that's this one. So it takes a slice and a new value. So so by slice they mean Golang slice. So an array is a fixed size, but slice is dynamically sized. So they call this slice. All right. So this is an array, but this is slice. This one, it's dynamic. Okay, nice. Now we know what is slice. So you see, for me, it's reading the code is faster than reading the language, which is not actually always good, because, for example, business logic will be written in English in the documents. And, well, this way, it's not the best way. Now, let's see what goes next. This we are not interested in. Why? Because, well, what is here in the fifth? So in the fifth we have we are adding slices with append. This one, which is actually built in Go. Oh, so there's built-in Go file. I'm not yet sure, but probably Go. It easily might be that Go might not have, let's say, classes or objects or whatever. It's a different language. You cannot compare it to, let's say, Java one-to-one. It has a little bit of C, a little bit of Python. It's like I can see different languages affecting it. Or shall we say different communities, or maybe, yeah, whatever. That won't help us too much. It's all like history of programming languages. So now this is easy, right? So, and this one, number 6. Well, actually, to be honest, friends, that's my mistake. So I shouldn't be saying easy, because we are all different, and like what is easy for me here will be hard for you, for example, and the other way around. What is hard for me will be easy for you. So here, to be honest, I'm not really reading through, because all I need to do, I want to see if the code changed, right? So I'm clicking here, it didn't change. Here, although, no, it didn't change, which means the change was here. And you see the tail. So apparently, so we remove the first element, right? And then we sum the sums and the tail. And the result will be, is it correct? If we sum all tails, and when we do that, we go through those through the slice, and for each number we take the, for each array we take the tail, which is end numbers, and which is the remaining of this array, and we sum the sums with the end. So basically the sums is the sum of the tails. So here, for example, sum of the tails is 2 and 9, right? And what we're doing here, it's an append, of course. So it will be 2 and 9 because we are adding, we are appending to the array of sums one more element, which is a integer, because sums is array of integers. So we are appending to the array one more cell, right, in which we write the sum of tail, which is this one, 29. If we had like this, let's say, then that will be sum of 2 and 3, and that will be sum of 9 and 5, which is 14. Now run. Did I understand correct? Yeah, I did understand correct indeed. That's good. Although here, like, it would be nice to have slightly longer example. Friends, we are almost there. We are almost there. Look, only 2 minutes is remaining, 2 blocks. So let's see, and it's only been half an hour. That's not bad. That's not bad at all. Now, package main, reflect testing, test sum. Let's see. Sorry, friends. Somebody wants to sleep. Now let's see. So we have this test. We run this thing. Okay, that's easy. Here we declare and initialize an array, a slice, which contains 3 digits, right? And then we sum them, and it's 6. That's fine. Now this one is more interesting because we didn't see it before in this form. So we have this checksums, and this is interesting because checksums does what? Checksums is just a variable, of course. Oh, we declare a function here. Look, this is a full-blown function. So this function takes a test or test object which is used. Well, it's actually a structure if we look here, right? I think it's a struct. Got and want, and then it checks it. What it allows us to reuse this function, right? So instead of declaring it somewhere, because if we declare it here, then, well, this method has access, but it doesn't need to. So it's quite easy. So we make stuff as local as possible, as long as it looks nice. Now we can run 2 tests with this one. So basically all he did is, which is actually amazing, Chris has refactored these things, and now he can reuse those methods, and that's beautiful, right? So yeah, this one. So that was pure refactor. Now we'll see this one. If there's anything new to us, there wouldn't be much. So this one we already knew. Sorry, so sleepy. Oh, this one is interesting because here we have some test which does the test, right? So this we already saw. Oh my god, this is something big. How does he explain it? Yeah, so somebody's, well, trying to impress us, right? So interesting. So here he created so he created methods, and I think he's really testing all the stuff, because this sum go can calculate tails. Yep. And then here, and then he moved stuff. Oh, he added like the whole API. You can find, you can reduce, you can do some banking. This is amazing. Like, you can immediately see it. Like, I really recommend you, friends, to just go here, right? You don't have to stop, right? Oh, we can, yeah. So you can go here, and here, right? We'll have folder arrays, and folder arrays in Chris's repo will have this bed bank, right? And take a look, and just try to understand what it means. For example, this one subtracts the transaction. So yeah, that's been the lesson for the day. So it's done. So next time we'll study what Key told us, or kind of inspired us to write. So that will be this one. So next time, which is hopefully in so this which I'm recording right now, I will record it for the morning, and then when I'm back, I will try to record another one for another morning, or maybe two. So the next time it will be structs, methods, and interfaces. And well, that's not a small one, but well, we'll manage. We're friends, we'll manage. In worst case, we can do 2 of them. So that's it. And thank you, friends. Live long and prosper. Bye.